The two main functions we use when finding different values on the normal model graph is normal CDF and infnorm. Normal CDF takes four inputs: lower bound, upper bound, mean, and standard deviation. The output it gives us is the percent of data that's within the two bounds. The other function we can use is infnorm. This function takes three inputs: area, mean, and standard deviation. Area is the decimal version of the percent of the graph we're using. And the output that we get from this function is the cutoff point of whatever percentage of the data we're finding. Problem 6 is asking what percentage of cars get less than 20 miles per gallon if we're using the normal model with 24 miles per gallon as our mean and 6 miles per gallon as the standard deviation. In this problem, we'll want to use the normal CDF function since we're given all the inputs needed for it. If we plug in these values into our normal CDF function on the calculator, setting the lower bound is -1 times 10 to the 99th, the upper bound is 20, the mean is 24, the standard deviation is 6, we should get an output of around 25.25%. Problem 7 is asking what mean we would need in order to have no more than 10% of cars under 20 miles per gallon. For this problem, we should use the infnorm function. In this case, we know two of the three inputs and what we want is the output, so we have to experiment with different values of the only input we don't know. So if we input 0.1 for the area, since we're trying to find the cutoff point for 10% of the data, 6 for the standard deviation, and a random number for the mean, we're trying to get the output to as close as 20 as possible. We can keep experimenting with different mean values until we get an output reasonably close to 20. Eventually, you should get a value for the mean of around 27.68 miles per gallon. Problem 8 is a similar situation to problem 7, except it gives us the mean value and has us experiment with different values for the standard deviation. We can use the same infnorm function on the calculator and plug in different values for the standard deviation. We should end up getting, with enough experimentation, a value of around 4.68 miles per gallon. Problem 9 asks us what the advantages and disadvantages are of using this new standard deviation from problem 8. One of the advantages that come along is since there is less spread, there are fewer cars on the very low end of gas mileage. The flip side, though, which is a disadvantage, is that there are also fewer cars that get very good gas mileage. The end.